Okay, we are back with some quick math. We are doing some functions. This is grade 10 content. Right. Like the videos, subscribe to the channel, share the content, drop a comment if there's questions, if there's something that you want me to cover or something that you want me to re-explain that you maybe didn't understand from the video. Okay, so on the picture that we're dealing with here, we have a linear function and we have a quadratic function. So we'll start with the linear function. Before we get into the questions, I want to make some comments, some generalizations, some things that we should know when we deal with our functions. Okay, so our linear function, generally equation is going to be y equals mx plus c. That's your general equation. You might see this equation as well, which is going to be y minus y1 equals m x minus x1. You might see that as well. Okay, when you want to determine the equation of your straight line. Some people use that. I choose not to. I prefer using just this one and manipulating that one. But if you see the other one, just be aware it is still a linear function, a straight line graph. Okay. um, anyway, so here we have two variables, y and x. Those are variables. Okay, and then we have two unknowns, m and c. They are unknowns. Okay, so y and x variables, they are things that constantly change, but even though they are constantly changing on our function, it's still the same function. Okay, m and c for this function is going to stay the same things. Yes, boy. Good job. M and C is going to stay the same thing. M is our gradient and C, well, C is our y, value of the y-intercept for this linear function, and that's fine. Okay, so we'll say this, let's say y, okay, not y, C is the y value of your y-intercept. Okay, but I also want us to just think about this for a second. Your constant, which is our plus C, for this graph or for your other graphs, it's going to be a plus q. That constant is the thing that shifts your graph up and down. So for when we think about the c value, that c value is the thing that shifts your graph up and down. Okay, great. When we think about m, let's talk about m a bit. M is your gradient, right? Gradient refers to your steepness. So m is your gradient, and when we think of gradient, we can have a positive gradient, so bigger than 0, or you can have a negative gradient, smaller than 0. So if your gradient is positive, then your function will be going up, right? So what do we mean when I say going up? I mean it's increasing. The values are getting bigger and bigger and bigger as you move left to right. So think of this is you, right? That is you are standing on the left hand side and you're always moving left to right. If you walk along your graph, are you walking up or down? You are walking upward, right? So this, we are saying the graph is going up. You have a positive gradient. M is positive, graph goes up. Okay, then the opposite is true. If m is negative, smaller than 0, your graph is going down. You are walking down as you walk along that graph. Okay, also when you think of gradient, let's just mention this as well. The formula of gradient is y2 minus y1 over x2 minus x1. Right, know the formula, now to use the formula. I don't know if we're going to use it in the question. We might not. I'll make a different video where I go over the gradient formula and some common errors that are usually made with a gradient formula. But when you think of gradient, you think about those things: positive, negative, moving up, moving down, those kind of things. You think about C, right? Let's just talk about domain and range for a second. Okay, so domain always refers to your x values. Okay, so domain, those are my x, all possible x values. So if I look at my function, my straight line graph, I'm going to draw in a green line here. So that green line touches your straight line graph, right? This green line also touches your straight line graph. If I continue to draw green lines, this straight line graph is going to continue to touch it. Okay, if I continue up until negative infinity, because of this arrow that you have, you are always going to touch your linear function. Okay, if you continue to positive infinity, you're always going to touch your linear function. Okay, so this arrow it also continues. So your linear function exists at all values of x. It doesn't matter where you pull one of these vertical green lines, you always going to touch your linear function, right? So your domain of your linear function is x is an element of real numbers. Okay, x is an element of real numbers. That means x can be all values. Okay, I like to express it in interval notation, so I'm going to say x is an element, and we say we start at negative infinity and we go up to positive infinity, right? Round brackets, because infinity is never included. But this says I start at negative infinity, I go up to positive infinity, so it's basically all values. So this is a generalization for all linear functions, all straight line graphs. That will be true. Okay, then the range for all your straight line graphs is going to be the same thing. Range, we talk about y values, and again y is going to be an element of real numbers, or you could say y is an element from negative infinity to positive infinity. I'm going to show on the graph again what that means. So now this time we talk about the range, we're going to look at vertical lines. So that vertical line, does it touch your straight line? It does. This vertical line, does it touch? Does it touch? Because of your arrowhead, it will touch until negative infinity. Similarly on top, because of that arrowhead, it will touch until positive infinity. So domain and range for your linear function, domain and range for your straight line graph will always be these. X is an element of all values and y is an element of all values. Make sure you know which one's domain, which one's range, which one is x, which one is y, because if they say give me the domain and you only give me this part without saying this part, then you won't get the marks, because I need to know that you know we are speaking of x values or we are speaking of y values when we talk about range. We'll do a summary on the parabola next, and then we'll get into the questions.